Hello, my name is Jeff Ginger. I am a research scientist at the University of Illinois. I work with Chad Lane in educational psychology. And for the past few years, we've been working on this thing called Project WHIMC, What If Hypothetical Implementations of Minecraft. This presentation is a brief overview of the different components of WHIMC and how they produce data that might be relevant to Invite. There are timestamps in the description in case you'd like to zip around to the parts that are most relevant to you. First and foremost, I'm not going to try to explain everything there is to know about WHIMC. There is a ton. You can watch this overview video that I made a little while ago that covers it pretty darn well. I will point out that the project has lots of components. So there's an astronomy simulation in Minecraft element to it, as well as a PBS Nova game with exoplanets and rescuing aliens and resettling them, where kids learn how we detect exoplanets. And I'm out here working in Boulder with the planetarium, running all kinds of camps, and we actually made a planetarium show and an exhibit to go along with it. So the project is cool in that there are a lot of points of intersection with kids and where their STEM interest triggers occur. What is probably most relevant for Invite is that we run summer camps, and we've been collecting data at these summer camps for a number of years now with a variety of different kinds of kids, all of these in informal learning settings in areas like planetariums and libraries and makerspaces and after-school clubs. These camps are more than just computer interfaces. It's really, the research is like a piece of the background of the camp. It's really not research with the camp attached, which I think is important, is that we're satisfying the needs of the community partners and trying to make sure it's interesting for the kids first and foremost, and the research is also part of the picture. So every day will involve some amount of presentation, discussion with kids between the instructors and between each other, as well as a lot of gameplay of a simulation, and then data collection and assessment, which kind of goes both ways of how much are the kids learning, as well as collection about the ways that they're creating things. And a lot of playful design. So I come from Fab Labs and makerspaces as my background, and so I'm really interested in kids doing things actively and not just being sort of empty vessels. We often also will have demos, and so here, for instance, the camps include going to Summers Bausch Observatory and actually seeing the telescopes in there, or seeing the planetarium film, or drawing exoplanets, etc. Something that I can thank Maya Israel for waking me up to is we use Universal Design Learning as our guidelines for how to create curriculum. So, in other words, there's a lot of technology-assisted curriculum, but really the backbone of it, the heart of it, is about engagement, representation, action, and expression, with the ultimate aim of expert learners who are purposeful and motivated, resourceful and knowledgeable, and strategic and goal-directed. There's plenty of research behind this. I'm not going to go in detail, but I think that this is really an important angle to have AI support, and I think it works really well with our resilience or grit collection of variables as well as collaboration. We're also doing a lot of supporting teachers. So it's not just me and staff at University of Illinois that are teaching these camps. We actually have a partnership with Ateneo in the Philippines, where every single kid in the whole country that is in public schools has a Minecraft account, because they have Office 365 with Minecraft Education Edition, which is really wild. So they've been a great partner to mirror our project. We have other partners in the US, in Maine and Colorado, and we've spread to other museum locations that are picking up our grant. And so we've had a lot of supporting teacher materials, explaining all the different components of what's going on in each of the simulation levels and what data can be seen and collected. More important to Invite is the research, data collection, and analysis that we are doing. So there are a whole host of behavioral, cognitive, and affective social science metrics that we are using. We've been taking field notes. Log data is a loose category. It can describe behavioral kinds of things. It's also really where AI and machine learning fall. We also do a lot of surveys about what kids think about things. We try to do interviews. We've tried those a few different ways, where it's the kid is separated versus an on-the-point cognitive interview kind of thing as they're doing something. One of my favorites is that we have them draw exoplanets and label them and explain them. And artifact analysis is absolutely one of my favorites, because it gets metacognitive and it really helps you see into things that the kid might not otherwise talk about when prompted out of nowhere in an interview. And then we've had evaluation pieces. So for a lot of it, we've done these things called self-evaluations or ICANNs. Now we're doing a science knowledge assessment, just seeing how much they've really learned, or how much they know coming into a camp and how much they've learned coming out of it. And we can, of course, compare and cross-correlate all of these. Matt Gadbury is the lead of research, who could talk more about them in depth if we need that. So one of the basic tools that we have in the game is kids can observe the environment, and they can do this by checking science variables, which are freely defined. So they might see that there's a lot of oxygen somewhere, and they might make an observation of there's a lot of oxygen there. And we try to get the kids to think in terms of evidence-based observations. So they notice something and they measure it, and then they say something about it. And eventually you can put these together to make theories or work with a hypothesis. And it's really kind of basic science stuff. But honestly, a lot of these kids have not done this in this context. They tend to do it in science class with like a worksheet. They're not doing it in a free open exploration game. As they're traversing throughout the server, we're also taking location data about everywhere they're going, and we can see what they're observing along the way. And this is neat that we can get a sense of how much they've explored and how in depth they've explored, what they visited throughout the server experience. One of my favorite pedagogical agents that we've employed is the photographer. So the photographer is actually a puppeteered account. It appears as Dr. Alicia Woods in the game, which is a character in the film. And Dr. Alicia Woods will go around when a kid makes an observation and take a picture of what the kid observed. That picture is then compared to a giant database of pictures that have already been analyzed, and an AI will spit out what it thinks is going on in that picture. It'll suggest an observation, and it will also try to rate the kid's observation. Now, right now, the AI is not very good because the database isn't very big, but we're making it better. And the goal is to not just be able to observe things in our Minecraft science worlds, but be able to do this in Minecraft of any kind, where a kid could take any kind of photo, we analyze it, and give them feedback in real time. And then there's this really cool dashboard that we can run at the same time where the teacher can see all the observations the kids are making, and so we can tell if they're off track or if they're observing things like, oh, there's floating carrots and stuff that maybe we weren't actually interested in having them do. And the teacher can also then use these. So the AI will suggest, hey, you might want to show this picture to the class of it's an exemplar, or maybe we typically don't shame kids in front of other kids, but it would alert the teacher to go make an intervention. And this becomes a really big deal because if kids figure out they cannot pay attention or just kind of like blow off an interface on day one, they might do that. And whereas we can let them know that we know more about what's going on. And I think it's a good exemplar of how AI could help teachers, of rather than teaching the unit or coming up with a curriculum, it's helping the teacher know more about what their students are doing and learning and where they might need help. The other two pedagogical agents are kind of mixed. So we have this little character you can summon in the game, and you can assign them a name and a skin and have a conversation with them. And that has been largely pre-written, pre-designed, where like they're hooking into the quests in the game and knowledge that is already pre-built about the world. But it becomes a vessel through which we could plug in GPT-4 or any number of other AI interfaces for this character to have a conversation with you in the game. Currently, it is only text-based, which is one of the reasons we've actually leaned away from it, is that we've noticed in a large pack, like in a group, kids want to talk to each other verbally. They're typically not reading large sums of text in the game. The more of that we do, the more it feels like forced school. But one of the other things the agent can do is you can ask them, how well am I doing on my observations? And they can give you an assessment. And we've been trying to teach them how to do comparative and descriptive and inference observations, and that this will help encourage them in one direction or another and tell them about them. The other pedagogical agent has two functions. One, it can help you build. So you can say, hey, follow me along as I build this solar panel, and it will build a solar panel along with you in parallel. And that's something we're testing just to see how much they might use the AI to extend or enhance their abilities. But the more exciting version of this is they build these habitats on Mars, and we are able to take the block data about what is in those habitats and what interactions the kids had. So you might have had kids working together, and one places down a block and another says, oh, actually that block should be this type of block, and they knock it out and they place in another of their own. We can get a sense of how they're overlapping and how they're working together and the process through which they build. And then all the AI needs is one or two pictures of this thing, and it can actually make a really good assessment as to if it's addressing the science variables we've been teaching them all week. So we're always telling them you can't just have doors that open up into the vacuum of Mars, you have to have an airlock. And air pressure is like really hard for kids to understand. They think of Mars in the way that you see it in sci-fi. They don't really know about what it's really like. And so this feedback can tell them, hey, your base is missing things to accommodate for gravity or air pressure or whatever, radiation, whatever it is, and suggest ways they can change it. This is actually not strictly part of WHIMC, but it's a closely related grant. We are also working with having kids learn to program in Minecraft. And there have been several tools that have come out of this that could be interesting for AI applications. One, as they write code with ComputerCraft, which is a Forge mod. So Forge is like a local instance only. It's hard to set up a server that is good for it because everybody has to have the same version, and there's lots of different versions and details to it. But Computercraft is sort of the predecessor of the robot agent that you see in Education Edition Minecraft. And in that, you write in text-based Lua code. And so we were testing to see if kids could be computationally creative, if they could use code to solve problems in interesting and creative ways, and if they could learn data science and data visualization using these robots. And as it outputs code, we can intercept that in real time and make comparisons of what they're changing. Now, for our camps, we mostly found that because these were beginning coders, most of the changes they were making were really just simple syntax, and like sometimes they'd rearrange a for loop. It wasn't really on the level of what we would call computational creativity, and that's mostly because they had only been doing this for a few days, and it was great they had learned so much so quickly. This is the kind of tool that if you were doing like a high school computer science class, you could really see the results of how are these students being creative and working with it. The scenarios for this were all STEM related. So illustrating concepts about the natural world with data visualizations and seeing ways you could do that in Minecraft. And there are lots of emergent AI techniques related to Minecraft. Many of you probably heard about NVIDIA's Mind Dojo, where they took like many thousands of hours of video of kids playing Minecraft on YouTube and giving tutorials on YouTube. And they were able to train an AI how to play the game with all of that video data. And I love that because like it's something like 50% of video content on YouTube is Minecraft. It's tremendously big. For those that don't know, if you've not learned about it or if you don't work with kids or something, Minecraft has been one of the top 3 most popular games for 10 years now. And it's stayed that way because of all the dimensions to it. And I love it because it's so empowering. Is that like in a lot of games, you're just like kill as many bad guys as you can or something. In Minecraft, it's about affecting the world. Everybody is empowered to change blocks, adjust the world, create their own story. The onus is on them. And that interactivity and that agency and that responsibility, I think, is fundamentally different than so many other games or TV or other sort of passive type media. Anyway, we're exploring other AI techniques, so we can use AI to do cluster analysis on observations. One of the big things we've noticed is that kids really hate writing and reading. It feels too much like school. And I mean, a lot of them are just doing less of it now. Like when I grew up, we had to read books cover to cover all the time. Kids are now often just getting little teeny snippets of information. There's arguments out there in Nicholas Carr wondering if kids' brains are being mapped differently because they're not doing sustained information interchange and they're just doing little inputs. So we're trying to find other ways to have the exchange happen. So this year we're focusing more on recording audio and seeing if the kids can talk to each other and potentially talk to an agent, and maybe we could have the agent talk to them to help puppeteer the experience, which I think could open up a whole bunch of different interesting learning pathways. And then we also have AI through pathing. Like, so when one of the kids asks, like, where do I go next? We have a pathfinding AI that is kicked in there. And there's possibilities with that where like it might lead them to somewhere else in the interface that they might not think of. So there's lots of depth and opportunity in this. Okay, the big elephant in the room is this question. Unfortunately, when people hear Minecraft, they think it's one thing. And Minecraft is actually kind of multiple things. So there's Minecraft Java Edition, and there's Minecraft Education Edition. They now call it Minecraft Education. Minecraft Education is based on Minecraft Bedrock. So the vast majority of children playing now, probably 95%, are playing on Bedrock. And they play in settings like cell phones, on tablets, on Chromebooks, on devices that are less computationally powerful. They can also play it on a real computer, so that's additionally confusing. Minecraft Java is the older version, it's the predecessor, and that's only on computers that you can play that. And we've been using Minecraft Java for all of our work because it's so flexible. You can pull in data and put in data. You can create mods. There's just a billion things you can do with it. It's so much more powerful. And unfortunately, Education Edition and Bedrock are more geared towards the make it as simple as possible and then try to charge lots of money. Lots of little microtransactions. If you want to get a skin, no, you don't make it, you just buy it. And that's really unfortunate, but it does have the uptake, is because it comes with Office 365 for many people, the packages they buy, the kids get to it automatically. And then one of the other big issues is that if you're ever going to do Minecraft learning in a school, most schools don't have real computers. They will have Chromebooks. And so Minecraft Education Edition is often the natural choice for schools. They've also done a really good job of leaning into things to support teachers. So while we built all this infrastructure of teacher guides and everything around Java, by default, anything made in Java doesn't have that. Whereas if you make an Education Edition level, you do an entry on the website where you say, is it beginner level? What ages? What's a video about it? Supporting handouts and worksheets and that kind of thing. It's all built out to support teachers. Now, this is good and bad. It's good in that it makes it easy to do entry-level stuff with teachers, and teachers can use existing levels. However, if teachers want to do custom levels of any kind, it's tremendously difficult. You have to design in Java and export out into Bedrock or Education Edition and convert everything. And it's very closed source in its current format. So, like for instance, with Java Edition, if we want to change what an NPC, an agent, is saying to a character, we can actually change that in real time as the game is running. With Education Edition, we have to redo the whole level and put in NPCs again and then change what they're saying. We might be able to script in some like they have translated language, so we could probably change the text on the fly. But there's just so many other pieces that can't be done on the fly. The biggest problem, notably for any researcher, is that getting data in and out on the fly is really difficult. Now, Chad Lane has made a contact with Layla, who is the person who's in charge of Education Edition, and we're hoping to make a pitch to them saying, look, we are this massive grant. AI is a huge thing that Microsoft cares about. If we want to be able to leverage AI and Education Edition, you have to open up this platform more. You have to give us live access to the database as we're running the game. Help us do this. Help create a set of tools to make this possible. There are so many great learning outcomes and so much possibility for Microsoft. I will also note that they have their own code builder agent, and that's interesting. I like it in a lot of ways because it can do block code. You can actually convert from block code to Java or Python on the fly, which is really neat. So everything in Education Edition, if it's going to be exported, can be done manually. If you stop the level, you can do block exports. If they take pictures with a camera in the game, they can export that as a PDF, which then can be analyzed later. If they do code, they can actually share that code out. But there are also a lot of problems. So like in Computer Craft, you can right click on somebody else's robot and see the code they've written, which is great. You can then share ideas that way. Whereas in Education Edition, you only get one robot and only you can see it. And there's a bunch of interface related challenges with all of this. So one of the things we have to decide for Invite is how we're collecting data and what it's used for. If the goal is to make a scalable Minecraft interface that can get to 2,000 kids in public schools with teachers, that's probably not Java Edition. That would be really hard to do. Teachers, in a lot of cases, IT at a school is handled by an external authority, maybe the county, and you put in a ticket and they're going to get to you like weeks later. They're not in the classroom helping you. And teachers may be in charge of their own IT, which like is kind of great, but then they don't have the passwords. They can't change what the firewall is able to get to, so they can't go to websites like YouTube. There are just so many restrictions in public schools that often the only kinds of interfaces you can do are web-based interfaces and the most simple, like manageable things as possible. So we do have some partners where we found we can do really cool education stuff, but this is why we mostly work informal, is that in informal settings, we often just have more access to the people that manage the infrastructure and can make these cool new innovative learning settings. Whereas schools, it's more like each kid doing their own thing, not talking to each other, all controlled by some faraway district authority. And it's just really not conducive to all that UDL stuff I was talking about earlier. To summarize the data outputs that we can do with WHIMC and Minecraft and AI, there are things that are more qualitative. So for instance, interviews, drawings kids make, which could be something an AI can analyze of like what they draw and do they label in enough? Is it actually a planet? Audio recordings, same deal there. We have about 100 of these kinds of things available from our data set over time here. They are in varying states of analysis. Most of the stuff like 2022 and earlier is done. The things that we're doing this summer obviously will not be analyzed yet. Anything coming out of Education Edition is a manual post-experience output only, currently, unless we can get to Layla and have them actually get developer time from real Microsoft developers to change how this works. We also have data that is more quantitative in nature. There are MySQL databases with user interactions within the system, such as pathing data of where they go, the things that they built, all the blocks they've placed, the commands they made, the code they've written, the observations they've done, the science tools they used. All of that is on the scale of thousands, sometimes even like close to 1 million with, for instance, location data. Those data sets could be the basis of informing an AI. And then on top of this, as I mentioned earlier, we have different interfaces. So there's the photographer interface, which goes through the chat to tell kids about things, but also through a secondary dashboard that can be shown on a teacher display or potentially on student computers. And then also a little agent, a character in the game that we can use to express different AI. So I actually think it's a really flexible platform for all the different things that we might want to do with Invite. The big Achilles heel is that it's really just best for smaller groups of kids where we have a technical IT person who's able to help. Okay, important question and answers. Do you have the personnel to make substantial changes to the system? For Java Edition, yes, we have a number of developers, myself included, along with a number of other students, to create new content and code new plugins. The time may vary for how fast we could push those out, but we do have people that are still working on this that I think we could engage in the next stages. Unfortunately, for Bedrock and Education Edition, we would need developers from Microsoft. We would need people that are not just experienced with Bedrock, but people who can actually change how Bedrock works from the Microsoft side if we want to be getting data in and out of that game. I think if we were able to pull that off and we could convince Microsoft to do that, which is in their interest with AI and education, then we would be making monumental change for people all over the world. For that system is so incredibly closed, and we would be essentially open sourcing something that is getting to millions of kids all over the world, which I would be so excited to do. But it's sort of above my pay grade. It's got to be people who are really powerful talking to other people who are really powerful. All right, permission from system owners and creators. So Microsoft is, in general, very supportive of this. There's more derivative works than they can keep track of. If it's like blatantly stealing accounts, they care about it. But from the get-go, they've been all about people modifying and changing. Java Edition has that written into its core. All the good ideas these people come up with, so many of them get sucked into the game and become real things. That's like where Education Edition came from with the robot, in fact. But I think discussions with Microsoft are a really good idea that we do this on the level so that, if we want to get them on board with, say, recoding Education Edition to be useful to educators that are more than just taking their pre-created products, then we want them knowing about it and doing it with them in partnership. Is the software architecture still up to date enough to be viable? Absolutely. So Minecraft is up to date all the time. 120 just came out. We're going to be one step behind that. Generally, the way this goes, they do a major update, and then like 3 to 6 months later, the community catches up with all the plugins and things. So it is an ongoing maintenance task that somebody like myself can do, but it is also will work on modern hardware. And if we manage to make this work with Bedrock, we get pretty much every platform imaginable. Education Edition can be on an iPad, it can be on a cell phone, it can be on a Switch, it can be on a whatever. Otherwise, we are looking at OS X, Linux, or Windows of some kind if we want to use Java Edition. Your overall recommendation, is this system one you would definitely recommend for people to propose future projects on? Minecraft overall, yes, absolutely. It gets a collaboration in a way that I think many agent platforms can't or won't. And the culture of it is very much about collaboration and building and kids telling their own stories. So I think that's a perfect setting. In public school settings at scale, the only option for this really will be Education Edition. And so that's the challenge that we're facing, is that if we're looking to get to 96,000 kids, I think was that overall impact number, that's got to be like really simple web interfaces, in my opinion, not complicated, cool AI stuff with Java Minecraft. But I think that's for everyone on the team to consider, and we might use this to inform other things. There also might be a way where we could have a companion app. So you have something like Education Edition running. It is possible to do extensions. They don't really have any documentation on like how you really do it and if you could run it effectively, but you might be able to do an extension or like a web browser running in parallel with it that's going to talk to a kid. So they play the game and an AI talks to them. There's maybe some ways we can run that. Or you just literally have like 2 computers there. That's another way to do it. So I'm happy to talk and think more about this, and I'll be in touch.